Okay, so we are now starting part three. Um, this is going to be problem 17, probably throughout the rest of them. So in this one, we're really dealing with heat exchange, so exothermic and endothermic reactions, what are those, and all of that. So looking at question 17, it says, which one of the following phase changes would be exothermic? So what I need you to know, we have this concept, system versus surroundings. System is the object you're observing, the surroundings is everything else. So if I have a pot of water here and I put a fire underneath the pot of water, and so I'm adding heat to the water, we'll say makes this statement. If energy is added to the system, then it is endothermic. So as we add heat to the water, causing it to boil, that is endothermic. All right. Um, Going on for here, if I have that same pot of water and I put it in the refrigerator, therefore the heat from the water goes to the surrounding. Um, that's going to be exothermic. So when you put something in the freezer, you are removing the heat from it. So the heat goes from the object to the surroundings, and then that is pulled out. Um, that's why like air conditioners and all of that have those intake vents that is drawing the hot air out of the room and pushing new air in so that the new air feels cooler. Um, so this is exothermic because the system is giving off heat to the surroundings. All right. Which of the following phase changes is endothermic? So again, we have to look for each one of these. Is it giving heat? Is the heat coming from the surroundings to the system? If it's coming from surroundings to system, it's endothermic. If it's coming from the system to the surroundings, it's exothermic. So sublimation, we are going from solid to gas. So that means that we have to um, add heat. That has to have heat added. Deposition, we're going from a gas to solid. Freezing, we're going from liquid to solid. Condensation, we're going from gas to liquid. From there, you should be able to figure out which direction energy is flowing. Is energy flowing in or energy flowing out? Which of the following substances is a liquid at room temperature? All right, so again, um, which one has the strongest IMFs? Um, is what you're going to look at. Which one is the most polar? Which one is most likely to have hydrogen bonding? Things like that. So on this, I'll go ahead and list from weakest to strongest. Remember that London dispersion is the weakest. Dipole is in the middle. And H bonds are the strongest. And remember that H bonds requires nitrogen, oxygen, or fluorine attached chemically bonded to hydrogen. Dipole must be polar and then typically nonpolar. So you'll have to draw the molecules on that one to get it. Which is expected to have the highest heat of vaporization. Remember, high vaporization um, high vape. Just caught this. I almost messed up on here. It wasn't asking for vapor pressure. It's asking for heat of vaporization. So another way to look at this question, which one is going to have the highest boiling point? B-O-I-L-I-N-G point. So which one of these is most likely to be a liquid? So in that case, we are looking again for strongest IMF. If it said lowest heat of vaporization, you'd look for the weakest IMF. So again, you're going to have to look at the structures, which one is most polar, which one has the strongest H bonds, things like that. All right, which of the following substances has the highest vapor pressure? High vapor pressure means weak IMFs. All right. So a weak IMF also is a low boiling point. So since they gave us boiling point numbers here, then we can look at that. We'll find the lowest boiling point. And so here, notice that these two both have the same boiling point. Now what we need to look at is which one is got the weakest IMF, and that could be from mass. So the smaller mass is going to have the weaker IMF. So weak IMF, low boiling point, low molar mass. Those are the three criteria you need to look at for that one. All right. So I had to, looking at this question, I want you to make sure you consider something in the question. Which of the following liquid substance has the highest vapor pressure at its normal boiling point? All right. So before we move off of this question, I want to give you the definition of normal boiling point. Normal boiling point is the temperature at which a liquid boils at 1 atmosphere of pressure. It's different from the simple definition of boiling point. Simple definition of boiling point in that the pressure is defined. The normal boiling point is more useful value when comparing different liquids since boiling is affected by altitude and pressure. So again, kind of the thing that you need to look at here is that the temperature at which liquid boils at 1 atmosphere of pressure. So at 1 atmosphere of pressure, all of these are at same pressure. All right. So therefore, all of them would have the same vapor pressure because all of them would be at 1 atmosphere at this point. That goes back to that original graph I showed in part 2. All right. Which of the following statements would be true about vaporization? It is the phase change from solid to gas. It is the endothermic process. The liquid must release heat to become a gas. None of the above statements are true. So vaporization goes from liquid to gas. In order to do that, we have to add heat. And since we are adding heat, that makes it endothermic. Which one of the following correctly ranks the compounds in order of lowest vapor pressure to highest vapor pressure based only on intermolecular forces? So that would be strongest to weak. So all of these are nonpolar molecules because I2 is iodine bonded to iodine, chlorine bonded to fluorine, and chlorine bonded to chlorine. So what we have to look at is total number of electrons. This one has the most electrons. This one has the fewest electrons. And you can look at atomic number for that and see that. So that means this one's in the middle. Remember, the more electrons it has, the stronger the IMF, because all of these are going to experience only London dispersion, but the more electrons you have, the more London dispersion you can get. So go from there on that one. All right. Which of the following correctly ranks the compounds in order of lowest boiling point to highest boiling point, based only on intermolecular forces? So weakest IMF will have a low boiling point. Strong IMF will have a high boiling point. So again, O2 looks like that. H2O looks like that. And carbon monoxide looks something like that. So again, what types? So this one is nonpolar. This one is polar. This one is polar. And it will have H bonding. So we have dipole, dipole. Figure it out from there. All right, number 25 and number 26 have to do with some math setup. This is kind of a combination of stoichiometry and some other things. So we have heat of vaporization here, 38.0 kilojoules per mole. The highlighted number may be different online. So everybody in yours, you may have different numbers here and here. What I'm going to do is walk us through setup and things like that. All right. So first things first, looking at number 25, we need to establish what is our givens. So given, we have 15.8 grams of CH3OH. And then we have a heat of vaporization that is 38.0 kilojoules per mole. All right, so one issue that I see right away is this is in moles, this is in grams. So step one, convert mole to gram. So the way that we would do that is take our 15.8 grams CH3OH, and then for every 1 mole, of CH3OH, there are 32.04 grams. All right, so you can check my math on that, whatever. All I did was calculate molar mass of 1 carbon, 4 hydrogens, and 1 oxygen. So 12 plus 4 plus 16 gives me 32. So if you did the full periodic things to go to two decimal places, you get 32.14. So doing this, 15.8 divided by 32.04 tells us that we have 0.493 mole of CH3OH. Now, I believe the question is asking you what amount of heat. Heat is measured in joules or kilojoules. So what we have to look at, and I'm going to go ahead and look at it on the problem here, our number is measured in kilojoules. So it's wanting our answer in kilojoules, which makes life easy because now we can use this. So we have 0.493 mole, and that's kilojoules to mole, so we have 38.0 kilojoules per 1 mole. So 0.493 times 38 will give you your answer. All right, moving on to this next one. How much heat is required to vaporize 115 grams of ethanol, C2H5OH? Heat of vaporization is 43.3 kilojoules. So again, first thing that we need to look at is step 1. Is convert grams to moles. Then you can apply the kilojoules per mole. And again, this number is going to be the same no matter what. This 115 might be different on yours. All right. Now, this one says determine the enthalpy of vaporization in kilojoules per mole of C6H14 if 14.5 kilojoules of heat is needed to do 5 moles. So, we have our given of, we have 0.500 mole C6H14, and we have 14.5 kilojoules of heat needed. All right. So one of the things that we have to look at is, will it be a positive or negative number in this and all of that. That's not really going to matter, I don't think. We'll come back to that. If it is a case, then we'll see. All right. Both of those for heat of vaporization. I'll double check. I'll double check in a minute. All right. So going into that, so let's look back at this original problems. So we were solving for kilojoules here, and we did this. So we want to, we have moles and we have kilojoules. And so basically, if we have 0.5, and we want it to be in kilojoules per mole, so if we have 14.5 kilojoules, and we divide that by 0.500 mole, our answer should be in kilojoules per mole. Yeah, so if we do that, keeping in mind the information that we had, setting it up like this will give you an answer at kilojoules per mole. And it's as simple as that. Um, and then we can go from there. And that concludes all of the information for Unit 12. All right. Again, this is due Thursday, May 7th. Please make sure you've completed this. I do have to enter a 0 if it's not completed by the 7th because I have to turn in grades on the 8th. So just know that. If you've been noticing, I've been updating the grades almost daily as you do work and turn it in, and go from there. With that stated, we will only have one unit remaining, which is Unit 11. My plan for that is starting on Thursday, I'm going to start posting information for Unit 11. I really want to be finished with Unit 11 by Wednesday of next week, possibly taking the unit test. For dual enrollment students, you are going to have actually 2 more tests because we need to complete the Southeastern stuff. So we will have a cumulative test that goes from units 9 through 12. And then we will have the final, which covers everything. What you should notice is if you go into your Moodle and you click on the previous test that you've taken, you should be able to see the tests as you've taken them with the correct answers versus the incorrect answers and all of that. I will tell you in the past, the final has been a combination of all the questions from the previous test. Still only 25 questions long, but it has questions that are very similar, if not the same, as the actual units test 1, test 2, and test 3. So just keep that in mind. The turnaround is going to be pretty quick on those. For dual enrollment, we have to be finished by the 20th. So just make sure that you know that. So that gives us 2 weeks to finish out everything and go from there.